Hi everybody, and thanks for joining us today. This demo features how Akamas AI-driven performance optimization solution integrates with Micro Focus LoadRunner Enterprise. We will show how Akamas can optimize the performance of a Java-based e-commerce application by using AI to automate JVM tuning. The first step to start an Akamas optimization is to create the system, which is a description of the application that I want to optimize. Here, I have created a system called Conacar that models a Java e-commerce application running in a Docker container. Our goal is to improve the application performance using AI to automate JVM tuning. So I have created a JVM 11 component starting from the Akamas Java OpenJDK 11 optimization pack. This optimization pack already contains 60 plus most important JVM parameters that can significantly impact application performance, so you do not need to know them all. Typically, performance engineers just tune a handful of them manually. With Akamas, you can tune many parameters at the same time. This applies to any technology, not just for the JVM. So the goal for this optimization is to maximize the throughput that our e-commerce application can sustain. In the optimization study that I have created in Akamas, the goal is set to maximize the transaction underscore throughput metric, which is the transaction per second that is gathered from LoadRunner Enterprise. Notice here that I have also included some constraints, as we want error rate to be 0 and response time under peak load to be less than 400 milliseconds for any configuration that Akamas will find. As you can see, we are requesting Akamas to optimize our most important service level KPIs and not some low-level JVM metrics here. Akamas AI will automatically figure out how to tune the JVM to achieve this goal and satisfy all constraints. In this study, I also set what are the parameters that we want to optimize. In this example, we start with 6 parameters of the JVM, such as the size of the heap and the inner pools, the type of the garbage collector, etc. And I also decided the duration for this study to be 50 experiments. But what is an experiment in Akamas and where does LoadRunner Enterprise come into the picture? An experiment is the way Akamas evaluates how good a given parameter configuration really is with respect to our goal. In an experiment, Akamas applies the parameters to the target system, such as the JVM, launches the load test, gathers the performance metrics, and then computes the score. You can see here all the experiments in this study. For each experiment, Akamas tracks which configuration was applied and its related performance score, which in this case is the number of transactions per second that the system could achieve under load. This score is automatically computed by analyzing the load test results, as we are going to see later in the demo. Let's now see what's inside an experiment. What you can see here is the set of tasks that are executed for each experiment. In this example, first of all, we apply the JVM parameters in a configuration file, then we restart the application, we wait a little bit that the application comes up, and then we launch the load test. Once you have defined your workflow, it gets automatically launched for each experiment with no more manual activities. What is important to notice is that the last step of the workflow is called test, and it is a LoadRunner Enterprise operator, which is the first part of the native integration that we have developed against the LoadRunner Enterprise. What this does is it triggers a performance test that we have defined in your LoadRunner environment, leveraging the LoadRunner Enterprise server APIs. If I click on the operator, you can see what you need to configure the integration. You need to provide information such as the address of the LoadRunner Enterprise server, the tenant, the domain, username, and password. You also need to tell Akamas which test and test set you would like to run. Those are LoadRunner Enterprise concepts that define the LoadRunner script, the schedule of virtual users, the load regenerators, etc., that are used to execute the performance test. This way, you can easily reuse your existing test and infrastructure for automated optimization purposes. We can see this concept in the LoadRunner Enterprise UI. I go to Test Management, then I can select my Conacar ramp-up test, where you can see the ID 186 that I have configured under Akamas. in the Akamas UI. Here you can see the name of the script that will be used to simulate some navigation of the e-commerce website, the load generators that I have used. You can see the shape of my scenario. You can see the test set that I have configured for this demo. So what we have seen so far is how Akamas launches a load test that you have already created in LoadRunner Enterprise. The second part of the integration is how Akamas collects performance test metrics from LoadRunner Enterprise once a test is executed. I go back to Akamas, and I go back to my Chronicle system. Under telemetry instances, you can see the LoadRunner Enterprise telemetry provider that I configured here. Within Akamas, we collect the performance test metrics from LoadRunner Enterprise via the integration with an influx database server, which is an analysis server that is natively supported by LoadRunner Enterprise. You can see here the kind of properties that we need to specify for this integration to work. I need to specify the address of the server, the database, the password, the port, and the username. You can see actually how this gets configured on LoadRunner Enterprise side by going into the LoadRunner Enterprise Administration UI. We need to go into the analysis servers, and then you can see here my influx database that I have configured. Those are the same properties that I have specified in my Akamas UI, and actually you can see the linked projects here, which are the projects under LoadRunner Enterprise that for which the load test will be the load test matrix will be pushed to this InfluxDB database. This is it as regards the integration setup. Let's now see how Akamas and LoadRunner Enterprise jointly work for optimization purposes. When the optimization study is started, Akamas drives the automated performance optimization. It launches the LoadRunner Enterprise test, it gathers the performance test matrix, and then it uses AI to optimize system configuration. We can see all the runs that are automatically launched by Akamas in the LoadRunner UI. Again, I go to Test Management. I select my test, Chronicle Ramp Up, and I click on Runs. We can see all the runs here that are automatically launched by Akamas as part of the automated optimization process. As you can see, most of those runs are executed during the night without any manual intervention. If I click on a specific test run, I can see all the usual performance metrics that LoadRunner Enterprise gathers as part of the test, such as virtual users, the transaction response time, the transaction throughput, etc. Those are the metrics that Akamas collects from the LoadRunner Enterprise integration via the influx database that we have seen before. Well, it's now time to go back to Akamas and see the results of this optimization study. In this chart, each dot represents a single experiment, which is the maximum transaction per second the system was able to achieve during the LoadRunner Enterprise performance test for a given JVM configuration. Each score is normalized against the baseline experiment, which is the first dot that you can see here. This represents the maximum transaction per second the system achieved with the default JVM settings. As you can see, after 16 experiments, Akamas was able to achieve a pretty significant 34% improvement in transaction per second. If we look at the time that it took to reach such a result, you can see that it was achieved in about 3 hours in this example. Normally, such a tuning activity can require months of trial and error manual processes, and it is done by experts. In this case, it was done by Akamas automatically in a matter of hours. If we go to the metrics tab, you can see the transaction throughput and response time that Akamas collected from LoadRunner Enterprise. This chart shows you basically the throughput and the response time for the two of the most important experiments of this study. The first one is the baseline, and the other one is the best configuration that Akamas was able to find. Notice that Akamas automatically also calculates the score of each experiment, and it does so considering the constraints that we have specified. we wanted a maximum throughput with the average response time of 400 milliseconds and 0 error rate. You can see, for example, that the baseline reached about 68 transactions per second with about 420 milliseconds of response time, while the best configuration actually was able to achieve a much higher transaction per second, actually about 93 transactions per second, with a response time even lower than 400 milliseconds. You can see that Akamas also automates the analysis of the load test and provides real-life performance score considering realistic constraints. The last thing that I wanted to show you is what I think many of you would like to ask, which is what is the best configuration that Akamas found that was able to provide such a significant performance boost without touching any application code or buying more expensive hardware. Let's go back to the summary tab and see what Akamas recommends for the JVM parameters. In this table, you can see basically all the JVM parameters that we tuned in this study, and you can see for each parameter what was the baseline value and what is the best value found by Akamas. You can see something very interesting here. First of all, Akamas found that the best garbage collector was parallel with respect to the default one in OpenJDK 11, which is G1. This is actually interesting because G1 is the default garbage collection, and it is well suited for keeping good latency and high throughput. But as we know, in the performance world, everything is application and workload dependent. So in this case, Akamas found that for this particular application, parallel was the best garbage collector, even though we wanted to have good latency and high throughput. Also, it changed the heap sizing and the internal pools of the heap. For example, it increased pretty significantly the heap and the size of the new generation, and significantly reduced the size of the survivor spaces. Again, some very interesting tuning that was found here. Another interesting change was what Akamas found as regard the garbage collection thread, the parallel garbage collection threads that you can see here. They were significantly reduced from 8 to 1. Again, this is counterintuitive because people often bump up this parameter in the hope of decreasing the garbage collection impact on application performance, in the hope of making the garbage collection process shorter. But again, best practices do not always work, and in this case, so many GC threads were not needed, and decreasing them can actually free up a CPU cycle to process additional application transactions. Well, that's all for this demo. I hope you enjoyed the new AI-driven approach to performance optimization offered by Akamas, and how the integration with Micro Focus LoadRunner Enterprise allows you to leverage your existing LoadRunner scripts and infrastructure to do the next step in performance engineering, which is to automate the performance tuning process.